This video is going to walk you through some of the basics of naming ionic compounds, specifically the binary kind, so 2 species. And back to our basic definition of ionic, it is a bond between a metal and a nonmetal species, or a cation plus an anion. Okay, remember your cation is your plus species and your anion is your minus charged species. So kind of your 2 basic rules that we can start out with regarding naming when you see a formula is the first is that you name the cation first. And we'll get to some examples in a moment. The second thing in these binary species is that the anion, if it's like a monatomic, it's going to take on IDE at the end of the name of the element, essentially. So, for example, chloride. So the chlorine turned into IDE. So let's do 2 examples here. Let's split this up. So we have COBr2. So we need to figure out what these are. So you're always going to name the metal first. And this is cobalt. So we have cobalt. And that's just something you need to start getting used to, looking at the periodic table and memorizing some elements as you go. And it will have a variable charge though, so we need to figure out which one it is based on what it's bonded to. This Br is bromide with a -1 charge. And because it's a -1 and there's 2 of them, what does cobalt have to be? It needs to be 2+. Therefore, this is where you start getting Roman numerals when you have variable charges with those transition elements. So you're going to have cobalt 2 bromide. Okay, this is where the IDE comes in. Instead of bromine, it's bromide. Good. Next example, Al2O3. Okay, first element, based on the periodic table, based on kind of just learning it as we go, we have aluminum. And does it have a Roman numeral to indicate a variable charge? No. It is always 3+. If it always is just 1 charge, then you just say the name. And then this oxygen is a 2- charge. And how do we say it? Based on our rule number 2 right here, we say oxide. And that's it, aluminum oxide. So hopefully this helps naming some ionic compounds that are simply binary.